Welcome to Chemistry with Mr. Brazil. Today I'm going to teach you how to calculate the frequency and energy for a photon, meaning light. I have a sample question here. What is the frequency and energy of a photon having a wavelength of 875 nanometers? Well, first I'm looking at that nanometers, and then there's some knowns which I provide to my students. One of them is c, the speed of light, which is equal to 3.00 times 10 to the 8 meters per second, and h, which is Planck's constant. That's going to be used for energy in a little bit. So 6.626 times 10 to the negative 34 joules second. And immediately, if you look at the constants that have been provided to you, you're going to notice that this is in meters and that's in nanometers. So let's convert that, the wavelength, let's convert that to meters. First of all, also, wavelength has a symbol called lambda, kind of a Y that's upside down. So lambda for us are going to be 875 nanometers, parenthesis, fraction bar, whatever units on top, put it on the bottom, that never changes. Meters on top. So they're 10 to the 9 nanometers. Well, I'm going to write this out. I'm not even going to use my calculator. 875 times 10 to the negative 9 nanometers. So this reciprocals up meters. So now we're in terms of meters. We can use C, and I've given you the equation which is, and it's in textbooks or online too, C equals lambda nu. Our particular textbook uses nu. Others use F for frequency, a curvy F. So let's isolate the frequency nu. So we're going to need to divide lambda out on both sides. So what you do to one side of an equation, you've got to do to the other. So lambda goes out. Therefore, nu equals C over lambda. Now you know you're doing your math correctly because C normally is on top. Okay, normally is normally on top. So when we're solving for either one of these, nu or lambda, C's on top. So 3.0 times 10 to the 8 meters per second, divided by our lambda, 875 times 10 to the negative 9 meters. Sweetness, the meters are going to cancel, and now we're going to be in units of 1 over seconds. 1 over seconds, that's a hertz. Okay, 1 over second, that's a hertz. So a hertz is equal to 1 over second. Okay? So let's punch this into the calculator, and we're going to determine that this is equal to 3.43 times 10 to the 14 hertz, 1 over seconds. Now we have our frequency. The other equation that you've been taught, or hopefully other teachers have taught you if you're new to me as a student, H times nu is the equation, the energy equation for a photon. H is Planck's constant, nu the frequency. Again, other textbooks have a curvy F. So let's put our values in. So we know that H is 6.626 times 10 to the negative 34 joules seconds, parenthesis, 3.43 times 10 to the 14, 1 over seconds. Again, this is sweetness because the seconds cancel, they're gone. Okay, they're going to cancel out, and we're going to be in terms of joules. And joules is a unit for energy. So plugging this into our calculator, 6.62. Now remember, with scientific notation, either use the E key or EXP key, depending on the type of calculator you have, and you should get an answer easily. And I got 2.27 to the negative 19 joules. Okay, 2.27 times 10 to the negative 19 joules. And that is the energy. So this is how you can determine, one, either, in this case, frequency, but you could use this equation to determine wavelength. We take this information, we bring it down, and we can put it into the energy equation for a photon, E equals h nu. So I hope you found this video helpful. Please continue to read about chemistry, learn about chemistry, watch other YouTube videos that other teachers out there have put out. And until next time.